Hi all. This video talks about one-dimensional arrays, 2D arrays, and strings. And before going further, firstly, my apologies for posting this with a delay. I do understand that our exam is tomorrow, but I'm kind of having a hectic week, and I'm supposed to take PhD qualifier examinations on this Friday. So I have to go through a lot of topics and be prepared for the exam. So as part of that, I couldn't post this video beforehand. So my apologies again that, but I'll try to make this as simple as possible so that you understand the arrays, string concepts in as simple as possible manner. So firstly, what are arrays? So far, or in C++, we work with a lot of variables. Like, for example, we create a variable of integer type and assign it a value. We can create a variable of float type and give it some value, and so on. So all these are something like inside the memory of the computer, we are creating a single space for A and hosting its value. We are creating a single space for B and hosting its value of 10.4. And when I say single space, this space is comprised of 4 bytes for A and 4 bytes for B. So this is the size that's allocated for an integer and for a float. This is what we have been doing. Now, oftentimes, we may need to do something like allocating a lot of blocks together. Like instead of a single block, we may want to allocate all several blocks together, and each block has its own size depending upon the data type of this block. So to do this sort of allocation, and if you notice, these are allocated continuously. So if we want continuous memory allocation and more than one block, then we go for something called as arrays. That's our first need. If we want continuous memory blocks to be allocated, then we go for arrays. The way we declare arrays is we declare in the same manner like how we declare a typical variable. We start with the data type, and then whatever the name that we give for that array or that particular identifier. As soon as we give the identifier, then we will be giving a couple of square brackets. Within the square brackets, we will be mentioning the size. The size is nothing but the number of blocks that we want. So this value here, this represents the number of continuous blocks that needs to be allocated. That's what the size denotes. And in C++, since C++ is statically typed language, we have to give the size of the array at the time of declaration. So this means I'm specifying 10 blocks of memory continuously for this particular variable called array, or for this particular identifier called array. So this is how it looks. And always it points to the first block. So if this is our array identifier, it points to the first block. So each of these blocks are indexed starting from 0 all the way till 1 minus the size that we want to create, 2, 3, 4, 5, 6, 7, 8, and 9. So 3, 4, 5, 6, 7, 8, and 9. So if we see the indices, these indices are in such that whatever the size is there, for example, here the size is 10. That means the indexes start from 0 and go all the way till whatever the value that we give for size and 1. So this means we are allocating 10 blocks of memory together for this array. And now if we notice, this data type is of integer. So integer. We know that for an integer, 4 bytes of memory will be allocated. Now in this array, we have 10 elements. So if I have an array of 10 elements, and each of these elements denotes integer type, that means we're going to allocate 4 into 10, 40 bytes for this array. So that's how space allocation is done for the array. So now that we have an array, so let's see how we can insert values into this array. So if you notice, the index starts at 0 and it goes all the way till whatever the size of the array minus 1. So that means we have a starting point, we have an ending point. And each of the indexes can be accessed by doing +1. So to access the array elements, we can simply write a for loop, start at the index 0, go all the way till whatever the size is there, -1. So either I can do less than 10 and do something like I++, and then, for giving the values of an array, simply I can do array of I is 0. So in this manner, what I'm doing is when this starts, I value is 0 and array of 0 is 0. That means I'm populating this value with 0. And the next pass, after incrementing the I value becomes 1, array of 1 will be 0. So in this manner, with the help of a for loop, I'm giving all the values to this array as zeros. So arrays and for loop, they are a good combination. The reason they are a good combination because all the requirements of a for loop, if you recall, have a starting point, have an ending point, and some mechanism to reach from start to end. So all of these are satisfied with the starting index, with the size of the array, and with an update statement. So arrays and for loop, they are good combination, and we can always access the elements of an array one after the other using a for loop. Now, yeah, sorry about the line here. This happens with my whiteboard sometimes. So up next, now that we have seen that, we just declared an array of integers, like with 10 elements, and then we used a for loop and then manually gave each value of the array to 0. This is one mechanism of initializing an array. Arrays can be initialized in several ways. We can also do something like this, int array, 10 elements, and then I can do something like this. So this means we are creating an array inside the memory with all 0 values. Index start, go all the way till 9. So both are equivalent. Either we can use a for loop to initialize an array, or we can use, whenever we are declaring it, we can give the values to 0. So both of these are legal. Now, another thing with arrays is we can access any element at random. For example, consider this element. The index of this element is 3. So I can do something like this. Array of 3 is 10. So this means I'm going ahead and I'm modifying this value alone. So if I want to access sixth element, I can simply do array of 6 and I can set it to 70. And this value becomes 70. So we can access array in this manner. And if I try to access an array that's out of the index range, see, the index is max value is still 9. But if I try to access it outside of it, this is illegal. And this is something what we call as array index out of bounds. And yeah, so far we have seen how to initialize an array in 2 different techniques. And sometimes we can also do something like this. We can declare an array, int array of, let's say, 5 elements. 5 elements I'm declaring. Now I can use a for loop. I is 0, I less than 5, I plus plus, and I can do something like reading the values from the user. This is totally fine. So this is how we can read array elements from the user as well. So this is pretty much about how we can create arrays and stuff like that. And if we want, we can also change this code to read array values from files. And the way we do it is whatever the file variable that we have, just simply put it into the array. So all these are legal. So yeah, that's pretty much about the reading in arrays from the user input, from the files, declaring arrays on our own in 2 techniques. Now, we know that array elements can be accessed using a for loop. So let's take a couple of arrays and see what all we can do. If I want to declare an array of characters, let's say character data type, I'm declaring an array. I'm declaring an array of 5 elements. And let's say these are the characters, HELLO. So I'm declaring an array of characters. This will be the snapshot of memory, HELNL and then O. So now if I want to print hello in the forward direction, the way I do it is I'll start at some point. So the starting point for arrays would be always at the 0th index, and the ending point of the arrays, remember, we are declaring size manually with a constant value like a number and so standalone number. So I'm using the same number and I'm doing I++ and simply do cout whatever the array of I, we can declare that array. Sorry, we can print the array elements. So the output of this is going to be an H. We can also do a space. So HELLO will be the output. Now, we can also do something like printing an array in reverse direction. How can we print an array in reverse direction? So if we carefully observe, these are the indices for this array, 1, 2, 3, and 4. So for printing in a reverse direction, this is where we have to start. So the starting point, if I want to print an array in reverse direction, would be the last index. So the starting point would be the last index. Now, that's the starting point. And where is the stopping point? The stopping point would be the 0th index. So go all the way till 0. And then the next thing that we have to do is from 4 to reach till 0, we have to subtract by 1 because I want to access 3 and then 2 and then 1 and then 0. So the difference is 1. So subtract by 1. And we can simply do cout of array of I. So if we notice, we are starting at 4, array of 4 is O. So O will be printed out. And then minus will come to index 3, will print out L, will go to index 2, will go to index 1, and then index 0. This is how we can print array elements in reverse order. So these are pretty much printing array in forward and reverse directions. The same can be applied with arrays of different data types. Now we'll see how do we do operations like sum of elements in array in a 1D array. So to do sum of elements, again, let's say I'm declaring an integer array. And this time, I'll also talk about something. Let's keep this one simple. Let's say int array of, I'm doing an array of 5 elements, 10, 20, 30, 40, and 50. I just declared an array of 5 elements. This is going to be 10, 20, 30, 40, and 50. These are the index values 1, 2, 3, and 4. So now how do I find the sum of all the elements? So for keeping the sum, I need a variable. So let's say I'll say sum is 0. I have a variable now. So let's take the snapshot of memory. This is the sum variable that we just created, and we are holding a value of 0 inside that. Now we need a for loop to access each and every element of the array. Started this, ended this. So this is the starting point. This is the ending point, and we have to access each and every element. So the I value will be incremented by 1. So int I is 0, I less than 5, and then I++. Sum will be whatever the value of sum plus array of I. So if we notice, we are creating a variable I. This is the value of it. Now, what is sum? Sum is 0. What is array of I? Array of I is nothing but array of 0. So array of 0 is going to be 10. So 0 and 10 will be stored inside sum. So now the sum value inside memory is 10. Now what will happen? We will be updating the I value by 1. So update I by 1. Now again, I less than 5, 1 less than 5, true, go inside. Now, what is the sum value inside memory? 10. And what is I? 1. So array of I will be 20 now. 10 and 20 will be 30. So update the sum value. Update the sum value. Now, update I again. If you are updating I, this time it's going to be 2. 2 less than 5, true. Now, what is the sum value? Sum is 30. And the next element inside the array is 30. Array of I, array of 2. Array of I is nothing but array of 2. So array of 2 is this element. So that means 30. 30 and 30 will be returned to sum. So sum is updated to 60. Now again, go back here, update I. Now array of I is array of 3, and array of 3 is 40, and the value of sum here is 60. This is 40. So overall sum will be 100 now. And lastly, update I. I is going to be 4, and array of I is nothing but array of 4. And inside array of 4, we have 50. And sum at this point is 100. So 150 would make 150. I will be 5. And is 5 less than 5 is the condition. Condition will break, and that's it. Now, if I simply do cout sum, this is going to be 150. So that's the way how we can compute sum of all the elements inside an array. So it's pretty much about how we do it. And in arrays, we sometimes do something called as finding an element. So let's say we have an array, integer array of numbers. Let's take 10 numbers. 1, 2, 3, 4, 5, 6, 7, 8, and 9. And I can also hold 10. So 10 numbers I have. This is how the array is going to look inside memory. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, my bad. Let me make this change. Okay, let me change this entirely. And I'm really not sure why these lines come up. Not even erase them. Come on. Let's say finding an element inside an array. Let's say we are declaring an array with 0, 1, 2, and so on till 9, all the numbers in consecutive order. So this is how the memory is going to look like. These are the indices: 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now, let's say I want to find an element 5, whether 5 is present inside this array or not. So whenever we have an option like whether something happens or not, whether something there inside an array or not, in all those instances, we create something called as a flag variable within programming. And this flag variable is of Boolean type. So we'll start by saying that no, the element that you're looking for is not there inside the array. That's what we'll start by saying. So now, if we take the snapshot of memory at this point of time, it's going to be an array of elements starting from 0 till 9, and these are the indices 9, and then we have something called as this is array. We have something called as find, whose value is 5, and then Boolean variable flag, whose value is false. This is the snapshot of memory. Okay, now the code we are going to write is, we want to go through all the elements inside the array. The size of the array is 10, start at 0, go all the way till 9. Okay, now while we are going through all the elements in this manner, every time we want to check whether the element and the value of find, are they equal or not, is what we want to check. So while we are going from 0th element to 9th element, what we are checking is the current element inside the array equal to the element that we want to find? If yes, then simply toggle the flag variable to true. Okay, and once we found the element that we are interested in, for example, the element at index 5 and the find element, they are same. If I found the element, there is no need to trace all the other elements. So to avoid going through the rest of the elements, I'll simply say break. So break will break the for loop. So now this is how we start. Start at 0, whether 0 and a find element are same, array of 0 and find element are same. No, then simply go and update the I value. I will become 1. Array of I and find, are they same? No. Are they same? Are they same? Are they same? No. It is when I is 5, array of I will be equal to find. So this will become true for I value of 5. At this point of time, what we are doing is we are setting the flag value to true, and simply we are breaking the loop. So to find an element inside an array or not, the logic we will be writing is, eventually once we are out of the for loop, if the flag value is true, we'll simply say element is inside the array. Else, we'll simply say element not found. That's it. This is how we figure out whether an element is there inside an array or not. So we have seen how we declare arrays. We have seen how to find sum of an element in arrays, printing the arrays in forward and backward directions. We have also seen how to find out whether an element is there inside an array or not. And some of the common other operations inside an array are finding the min element, finding the max element, finding the average, etc. So we have already seen these through lab exercises. Please go through the logics ones. And we also have these in our slides. Please go through them. And yeah, that's all pretty much about one-dimensional arrays. And one last point before concluding, we can also use an identifier. Like for example, if I want to declare an array with 100 elements, okay, what I can do is I can create a variable size. Okay, so this is like I'm declaring an array, but the array size or the number of elements comes from this variable or identifier. So size is the identifier. Now, this size, the way we have to declare is, this size should be of constant type, or this size should be a constant. So the way we declare constants is a constant keyword, data type of that particular identifier, and then size, and then 100. So this is legal in C++. What's illegal in C++ is, if I do not say the constant, and if I simply say size as 100, and then if I do integer array, and if I use the size as a reference to get the number of elements, then this is illegal in C++. So this doesn't work in C++, and this is how we should do it. So overall, that's all to discuss about one-dimensional arrays. And I thought I'd do strings in this video, but this video became kind of lengthy, I believe. So I'll do strings in the follow-up video.